Welcome to chemistry class. Before video, we have discussed about how to identify molecular orbitals and what are molecular orbitals. That these things we have seen, and one example also we have seen. Let's come to second example. H2 plus molecule or H2 plus ion. Let me write the molecular orbital diagram and all these things for H2. MOED of H2 plus, let me see. And in this case, one H is combining with one H plus. H has 1s1 configuration, H plus has 1s0 configuration. Means no electron in H plus. After losing one electron, we got that one. So this is atomic orbital. I am writing here one atomic orbital, one atomic. This is atomic orbital of H. This is atomic orbital of H plus. This has one electron. This has no electron. By the combination of these two orbitals, we get two molecular orbitals. So after formation of molecular orbitals, atomic orbitals disappears. Already I told you. And here, this is called sigma 1s bonding molecular orbital of H2 plus, and this is sigma star 1s of ABMO of H2 plus. This is H2 plus ion, and here only one electron is there. So this is energy diagram. This is energy diagram. Bonding molecular orbitals has less energy. Anti-bonding molecular orbital has more energy than atomic orbital. This is atomic orbital, 1s atomic orbital of H. This is 1s atomic orbital of H plus, no electron, and only one electron will be there. That will be present here. And if you write the configuration for H2 plus, sigma 1s only has one electron, no electrons in sigma star 1s. Bonding molecular orbital only one electron, anti-bonding molecular orbital does not have any electron. So if you write the bond order for this, already I told you the formula is 1 by 2 NB minus Na and 1 by 2 1 minus 0. So that bond order will be 1 by 2. Bond order will be 1 by 2. Half bond order will be there for this. And magnetic nature, if you see magnetic nature, if we see for this, already I told you, if unpaired electrons are there in molecular orbitals, bonding that is, it has the magnetic nature. If no electrons in molecular orbitals, after writing electronic configuration, it is diamagnetic. If you observe this one unpaired electron is there in a bonding molecular orbital, so it is paramagnetic ion, because one unpaired electron is there. Paramagnetic is there. If paramagnetic is there, we have to calculate magnetic moment. The formula is mu equal to root over n into n plus 2 Bohr magnetons. Why this formula is there? Let me discuss later. It is not the time to discuss all these things. So mu equal to root over n into n plus 2. N means number of unpaired electrons we have to take. Number of unpaired electrons. So here n equal to 1 is there. So if you substitute that one, mu equal to root over 1 into 1 plus 2 will be up here. That is root 3 Bohr magnetons will be up here for that. Root 3 Bohr. Root 3 means it will be 1.73. Root 3 value is 1.73. So 1.73 Bohr magnetons will be there, means a weak attraction towards the magnetic field will be present. Paramagnetic means what? If any substance is placed in the magnetic field, if it is weakly attracted by the magnetic field, we can say that orbital as molecule, that substance as paramagnetic substance. That is possible if it has the unpaired electrons. Here one unpaired electron is there, so H2 plus ion is paramagnetic. Remember, in previous example we have seen H2 molecule that doesn't have any unpaired electrons, that is diamagnetic, but here it is paramagnetic. Let's go for another example. Everything is only like this now. Don't be confused. Go through step by step. You will understand easily. Subject is not tough. Remember, if you are going in step by step, The chemistry is not tough, MOT is not tough. And one more thing, the student will get, he is brilliant student, he can understand, he will get, he can remember, like that don't say. You are also same type of brilliant nature, you are also has the same type of memory. Only thing is you are not getting concentration, you are not giving much importance for that without knowing by you. That's why you are not getting. About another person getting knowledge, getting marks means what? He is getting interest because he knows the importance of this thing. So if you do that one, you will also get understanding. This is no dull student, no top student here. Remember, top dull only decided by the timing, not by the person. In that time, if you practice, you will get the marks. In that time you are wasting, you will not get the marks. That only the difference between the students. From my side, I never say he is brilliant student, he is dull student. Both are same. Those who are using the time properly and practicing like this step by step, by knowing everything, is brilliant. Those who are not using that one is not brilliant. That's all. So let's go for next example, H2 minus ion. I'm going step by step. First I wrote H2, then I wrote H2 plus, now I'm writing H2 minus. All these things previously asked. I'm not writing time pass examples. Remember, I'm not writing time pass examples because I'm not taking these video classes for time pass. I am giving these classes only for the students to get the knowledge. Every student has to get the success. Every student has to get the subject. That is my motto. That's why I'm explaining. So I'm going one by one. So next H2 minus I'm taking. Here also two hydrogens are there. One hydrogen is H, another one in hydrogen is H minus. So means one extra electron present here. Its configuration is 1s1, its configuration is 1s2 because one extra electron is there. So, and the atomic orbital of this hydrogen, if it is right like this, atomic orbital of this hydrogen, if I write, it has one electron, it has two electrons like this. This is 1s atomic orbital of hydrogen. This is 1s atomic orbital of H minus. And by these two combination we get two molecular orbitals. I told you, one is bonding, another one is anti-bonding. Sigma 1s we get, sigma star 1s we get. Sigma 1s we get, sigma star 1s we get. Here total 3 electrons are there. After disappearing these small atomic orbitals, next electrons goes to this molecular orbitals like this. 2 electrons here, 1 electron here, because each orbital maximum capacity to hold the electrons is 2. So after filling 2 electrons in bonding, third electron goes to anti-bonding. So if I write the configuration for this, H2 minus, if I write sigma 1s orbital has 2 electrons, comma sigma star 1s anti-bonding orbital has 1 electron. Here it has 1 electron, it doesn't have no electron, but here it has 2 electrons, and because 3 electrons are there. And if you write the bond order for this, BO same 1 by 2, NB minus Na means 1 by 2, bonding has 2 electrons, anti-bonding has 1 electron. Overall it will also be 1 by 2, because half into 2 minus 1 means 1. Here 1 minus 0 means 1, here 2 minus 1 means 1. So half. Here also bond order is half. Their bond order is half, here bond means in H2 plus bond order is half, in H2 bond order is 1, in H2 minus bond order is half. After that, magnetic nature, if we see, magnetic nature. Magnetic nature, if you see, please be careful. Magnetic nature, if we see, here pair is there, but here unpaired electron is present. If already I told you, if unpaired electron is there, it will be paramagnetic. So H2 minus also paramagnetic, H2 plus paramagnetic, H2 is diamagnetic, H2 minus is paramagnetic. And magnetic moment, if you calculate, root over n into n plus 2 Bohr magnetons, One Bohr magneton value is EH by 2 pi r, like that is there. Like we'll discuss that one later. And N is there. Here N equal to 1 because only one unpaired electron is present here. If I substitute that one, same thing, root into 1 plus 2 equal to mu equal to root 3 Bohr magnetons will be there. Root 3 value is 1.73 Bohr magnetons. Like this, you can identify molecular orbital for H2 plus and H2 minus. H2 plus and H2 minus. So this is electronic or that is molecular orbital diagrams for H2 and H2 plus. Like that, let me write for He2 plus, He2 minus, lithium plus, Li2 plus, Li2 minus, Be2 plus, Be2 minus, C2, next B boron, B2 plus, B2 minus, you can write anything like that. So here H2 plus. These are the two examples I wrote. After that, let's go for another example, He2. After that He2, directly I will go for Li2 plus. After Li2 plus, I will go for Be2. After that, I will go for B2. So like that, let me see now. First, next example here is I am taking He2. Is it possible or not? Let me see. In He2, two helium ion atoms are attached. So He2 means two helium atoms forming the molecule. In this case, configuration is 1s2. In this case, configuration is 1s2. Total 4 electrons. Here we are getting total 4 electrons. So this is 1s of helium. This is 1s atomic orbital of helium. This is 1s atomic orbital of helium atom, and we get two molecular orbitals. Same thing like this. This is energy diagram. This energy diagram. So energy diagram it is, not simple things I am writing. This is energy diagram. Here it has two electrons, here it has two electrons. This is sigma 1s, this is sigma star 1s. We get here two electrons, here two electrons. After disappearing atomic orbitals, two electrons here, two electrons here will be, right. These will be disappear and the two electrons will become here. These will be disappear. Remember, here two, here two, here two, here two will not be present. These two only coming here, because after molecule formation atomic orbitals will be disappeared. So like this we get. And if you write the configuration of He2, sigma 1s has two electrons and sigma star 1s has two electrons. And bond order, if I write 1 by 2 Nb minus Na, if you take 1 by 2, 2 minus 2, we get 2 minus 2 means what? 0. 0 into 1 by 2 means 0. 0 means what? No bonds between two helium atoms. And means helium atoms never form any bonds. Helium atoms never form any bonds because we are not getting any bonds between them. We are not getting any bond order between two helium atoms. So the bond order is 0, no bonds between them. And if you observe the magnetic nature, no unpaired electron in this. Here it is paired, here it is paired. So He2 molecule generally never present. No need to discuss about magnetic nature, because molecule does not exist. Why? Because bond order is 0, means no bonds between helium atoms. So no need to discuss about magnetic nature. Like that, you can identify the MOED of He2 plus, He2 minus. In this case, total electrons will be 3. In this case, total electrons will be 5. So you can write MOED of like that. After that, let's discuss about Be2. Another example Another example, Be2 I am taking. Beryllium molecule, Be2, will it exist or not? Is there any bond order or not? Let me see. One beryllium has 1s2, 2s2 configuration. Why? Because its atomic number is 4. Another beryllium has 1s2, 2s2. Total 8 electrons will be there in this. Total 8 electrons means one beryllium has 4 electrons, another beryllium has 4 electrons. 1s, let me write 1s orbital of atomic orbital of one beryllium, 1s atomic orbital of another beryllium atom. These two will form two molecular orbitals as I said in previous examples, and this is energy diagram order, and here it has 2 electrons, here it has 2 electrons. Please be careful. 1s2 in one beryllium, 1s2 in another beryllium. Already told you, molecules form bonds, not only valence shell. From 1s orbital bond formation takes place according to MOT. So I am writing from 1s. Here 2 electrons, here 2 electrons means total 4. 2 electrons in sigma 1s, 2 electrons in sigma star 1s will be there. Like this, sigma 1s has 2 electrons, sigma star 1s has 2 electrons. After that, next orbital is 2s. 2s atomic orbital of beryllium, 2s atomic orbital of another beryllium, because 2s of this, 2s of this. These two once again form one bonding orbital and another one is anti-bonding molecular orbital. Like this it will be formed. This is 2s, this is 2s. 2s2 is there, 2s2 is there. So total 4 electrons means sigma 2s has 2 electrons, sigma star 2s has 2 electrons. Why? Because 2s orbital also overlaps straightly. 2s orbitals also form sigma bonds. So sigma 2s, sigma star 2s, sigma 2s2, sigma star 2s2 will be there. Like this, molecular orbitals formed and atomic orbitals disappear once molecular orbitals are formed. Then if you see the configuration of Be2 molecule, Be2 molecule configuration, if I say sigma 1s has 2 electrons, sigma star 1s has 2 electrons. After that, sigma 2s has 2 electrons, sigma star 2s also has 2 electrons. Like that, electronic configuration will be there for sigma 1s or sigma star. And bond order, if we calculate, 1 by 2 Nb minus Na will be there, 1 by 2. Total electrons in bonding molecular orbital is Nb. This is bonding molecular orbital 2 electrons. This is bonding molecular orbital 2 electrons. No bonding orbital. This is anti-bonding, anti-bonding. So total 4 electrons as Nb. And here also 2 electrons in bonding orbital, 2 electrons anti-bonding. Here also 4 is there. 4 minus 4 means 0. 0 means the bond order in this case also we are getting 0. If total electrons are 8, there is no bond between two beryllium atoms. There is no bond between two beryllium atoms. Bond order here also we are getting 0. 14 3, 13 2.5, 12 2, 11 1.5, 10 1, 9 0.5 is 0, right? So 0 bond or no bonds between beryllium atoms. The concept of this is no bonds between beryllium atoms, because bond order is 0. And magnetic nature, if you observe, here 2 electrons pair, here pair, here pair, here pair. All electrons are paired here. All electrons are paired means no unpaired electron. No unpaired electron means n equal to 0, then mu equal to 0 boromagnetons means it is diamagnetic compound. Be2 is diamagnetic compound. Like that you have to write molecular orbitals for Be2. In the same way, Be2 plus, Be2 minus. For this also you can write molecular orbitals. If you are not getting, just do comment. I'll solve that one as a separate example. I'll send to you as a message, or once again I will explain in a video. So Be2 plus means in this case 7 electrons will become, and in this case 9 electrons will be there. How the molecular orbitals will be there for these 7 electrons, and how the molecular orbitals will be there for this 9 electrons, you can try same like this. Same like this, and this is molecular orbital energy diagram for Be2. Like that we can go for another example in another video. Thank you.